In the documentation page that Yanis presented, we have a specific, in the documentation website, we have a specific page for porting a model to the VLAB. So as we saw, the requirements are for this example test to work, to have a Docker Hub account and a GitHub account. So first of all, we need to create the code repository and upload it to GitHub, and then we will see how to create, test, and share the Docker image. After these two tasks, we will see how to enable the VLAB to interact with those resources. So, create the code repository and upload to GitHub. As we saw in the slide in my last presentation, you can interact with Git either using the command line or a client application. In this documentation, we are using the GitHub desktop application, and you can replicate this using any other application that you prefer. So we open the GitHub, and the first thing we have to do is to create a repository that we will call VLAB test repo. So we open it, we create a new repository, we give the name, you can select the local path on your PC, and you create the repository. The next thing you have to do is to publish this, at the moment, empty repository. To do this, you need your GitHub account that this client will request you. I am already logged in, so I publish the repository. Okay. No. Okay, yeah. This is an error because I cannot create a private repository. We have to remember to untick this, and we can publish the repository. There we go. And there we have our repository, which has been published. Second thing is to download the model example source code. Here you have the link. I have already downloaded it, and it is available here as a zip file, which I have already unzipped here. It's very simple. It's just a couple of files that we are going to use. This code takes a Sentinel-2 image and transforms it into a PNG file. So really basic functionality. We copy these two files to a source folder. Okay, in my case, I will use this. I have this VLAB test repo, which I have just created, and I copy the files here. Okay. Now, what we need to do is to update the online repository with the files that we have just added. So I go back to the Git client application. Here I have the two new files. I write a comment for this commit, files added, for example, and I commit. Once the commit has been done, I push the commit to the remote repository. Okay, so pushing, and now the, let's say, model is online. Now what we need to do is to create, test, and share a Docker image. As I was saying, this example code can take a Sentinel-2 image and transform it to PNG. It is written in Python, and it utilizes the ESA Python libraries. So the ESA snap library written in Python, which is called Snappy. So how to create the Docker image? Let me open, okay, let me open a terminal, because Docker can be configured using command line. Okay, so here I have my model, very simple. This is the Python script which takes the image and transforms it to PNG. So the first thing I have to do is to launch a Docker container. Since I'm using Python, I use an existing Docker image which is providing the Conda software to allow a simple installation of Python libraries. So this is the command to run the image. It is Docker run. You can give your container a name, and then you can you can mount some volumes on your container. In our case, we want to mount the source folder, so the folder where we have the source code, and a data folder. We provide here an example Sentinel-2 dataset that can be downloaded, and which I have already downloaded because it's quite large. So I will cut and paste this command to the terminal, replacing the source folder and data folder with my actual folders, local folders. So this is where the source code is. Okay, webinar folder, webinar model, and VLab repository. And then I replace also the data folder with my actual data folder. Okay, webinar data, I have to double check if I have copied already. Webinar data, yes, I have the Sentinel-2 zip here. So now I launch the command and I run the container. Now here I am inside my container. So let's say I am inside my virtualized environment. What do I need to do next? I need to configure this environment with the software and the libraries I need to execute my code. So I have started from this Anaconda version. I don't need to install Python because it is already present in the image I started with, but I need to install the ESA Snap Python software. So first thing is I create a Conda environment, which means that I will create an environment where I will install all the required software. And I call it snappy env, which stands for Snap Python Environment. This is asking me if I want to confirm the installation of all these packages. As in the documentation, I type yes, and go. So this is installing what is required for Conda and for creating a Python environment with version 3.4. Okay, there we go. So now the environment has been created. Now I need to activate it, so I copy the command which is here and I activate my Conda environment. So now I'm working with Python 3.4. Next thing I have to do is to install the Snap software. So I create a directory for installing it. I enter the directory and I launch the wget command in order to download the installer on my container. I hope it will not take too long for the download of this. So what we are doing, as I was saying, is to create the environment which is needed to run the model. You can utilize the source code, the programming language you want. You can utilize the libraries you want. What you need to do is to create a container which has all the required software installed on it. So this is the advantage of using Docker. When you have this container in place, you can move it and deploy it on any host which has a Docker installed, a Docker software installed. Of course, the first thing you have to do is to prepare this container. Okay, we are at 75%, so almost done. The documentation here, you can replicate it as it is. So we are providing, as you see, all the commands, even the most simple ones, such as cd snap install. So you can just cut and paste all the commands which are here. You have also these tips here where we tell you where you can customize. So this is using the example model, but if you want to use it for your real model, you have all these, let me call it extension points. So you can customize here. And if you use a Windows system, you might need to use slightly different commands. When we find it, we provide you with this information. For example, the first command here to mount the data folder and the source code folder has a slightly different syntax in Windows than the one you have on Linux and Mac. So we are trying to cover all the possible use cases. So we are, let's see, okay. We have downloaded the installer. So now we can install the ESA-Snap software. We run the script and we are prompted with a set of requests from the software. Here we have prepared all the answers and all what you have to type when you're prompted with questions. So oh, yes, then one, and yes, then sorry, I go here. Okay, so now just enter, enter, yes, enter, yes, okay. Then here, when you are requested with the Python executable, you need to provide the executable in the Conda environment we have created. So this is it. And this is now extracting and installing. Now, no. And the Snap software has been installed. It requires some configurations, so all the configuration commands are again reported here. First of all, we need to configure by providing again the Python executable. And then we have to modify a configuration in order to increase the maximum memory to be used, because the transformation of a Sentinel-2 file is requesting more than the default memory. Okay, so the first has gone, then we go here, we change the memory configuration, we run the setup for Python, there it is, and the last two configurations which are required in order to link a couple of native libraries. There we go. Okay, so now we have installed the Snap software. Another software which is required by our model is actually the unzipping software, because the Sentinel-2 data come as zipped files. So we run the apt-get install for unzip. And there it is. So now we have, let's say, completed the environment preparation, and we are ready to test if our model can be executed in this environment. So we go to the source folder. The source folder here is s2png, because it is, if you recall our first command, it is where we mounted the source folder at the beginning. Okay, so we go to this folder, we make the run sh executable. This is run sh. We can see it, very simple. It just unzips the files and invokes the Python script for the transformation. We make this executable. We create a data directory, and we copy to the data directory the example data that is in this folder. Again, this folder test data is where we mounted the data folder on our local PC. We execute this copy. And now we can test. So essentially, we launch the run.sh. And now it is executing the transformation. This will take up to 5 minutes, I don't know. Okay. So what we will have at the end of the execution is this PNG file, which is the Sentinel-2 data we have downloaded. So this is essentially what it means to create a Docker image. We need to define the environment that is requested for our model. If we use Java, we need to install Java. If we use, Fortran, we need to install Fortran compiler, and so on. Whatever your model requires, you need to install it on this environment. We will see in a short how then we can save this environment and share it with VLAB. Do you have any questions while we are waiting for the run to complete?
Yes, this is Guy. I have a question. Is it, in principle, possible to create a Docker template that already has installed, let's say, Fortran compiler, or a Docker template that already has, the kind of usual?
No, I understand. This makes a lot of sense. What we are doing now, we are collecting, let's say, from the modelers that we are interacting with, we are collecting this kind of information. The idea is, yes, to provide in the next months a set of predefined images that might cover not all the possible libraries, but might cover, I don't know, 70%, 80% of the use cases, so that it will be much easier for modelers to start working with it. They might not even need to create their own Docker image, because the default one for, let's say, Fortran, or default one for Python is already working. It already has all that they need. So yes, this is a very good point, and indeed we are working to collect the information that we need to provide these default images. Of course, then you will always have some use case where the default image is not enough, and then the modeler needs to know exactly how to create a Docker image and so on. But for sure, even with default images, modelers might need to know how to test those images locally, because it's useful for them to test locally. They can also use VLAB for testing directly, but it might be more efficient to test locally. So I hope this answers your question, Guy.
Yes, it does. Thank you.
Okay, so here the execution has completed, and as reported in the documentation, we have the S2 file, s2.png file in our data folder here, and there it is. Okay, so this is what we expect to find. So the test has been successful. This means that we were able to create a Docker image, to create a Docker container which is able to execute our model. So we are ready to create an image from the container and to share it. First of all, we clean our container, removing some of the temporary files which have been created during the model execution. Okay, so how to create an image from a container? Essentially, you have in Docker this commit command, Docker command, which takes the snapshot of your running container and automatically creates the image, so the template for you. You don't need to edit Docker files to use complicated things. You have created the container, and then essentially you just say, save it in the Docker language. So you open a new terminal and you run this command where you will replace this Docker Hub username with your Docker Hub username, of course. Here I will use the VLab username and I save it. So this is creating the image from the container. So it's creating the template. It is saving essentially all the information, all the required software that we have installed during our process. And then in order to share it, we run this Docker push command, that's similar to the push of GitHub. Okay.
Mattia, where are you pushing?
I am pushing to Docker Hub. It is like a GitHub, but for Docker images.
So the Docker people has created a cloud environment for you to push Dockers there.
Exactly. It's like, you know,
Okay.
Docker Hub is the equivalent of GitHub for Docker.
Yeah, but instead of sharing code or readable things,
Exactly.
you share binary
Docker images. Yeah, essentially. Yeah, exactly. Exactly that. So now it is pushing our image. It will take some time because it's quite large, but I have already pushed before this webinar. So since we are running a bit late, I will go through this. So now we have the code, we have created a Docker image which is able to run that code. How do we interact with VLab? VLab essentially needs some information in order to execute your code. And the information that are required are which are the input and the outputs of your model, which are the scripts, so the source code files and the scripts files which are needed by the model, and which is the Docker image to be used. So you can provide this information to VLab using 3 JSON files that you will add to your Git repository, so that when you share the Git repository URL with VLab, the VLab will search for that folder and will search for that files and will fetch there all the information that are needed in order to run the model. So again, here you have a step-by-step guide. When we start this, we have VLab repository with only the 2 files of the model. So we create the VLab folder in our repository. Okay. new directory VLAB. And then what we need to do is to add the files which are required. First of all, we add the input-output description. This is encoded in a file called iodescription.json. So we add a new file. Okay, and this has a schema for providing information about the input-output. Essentially, here you define how to ingest input data into your model. Okay, in our case, how does it work? You give any input an ID. You can say what type of input it is, if it is an array, a single value, and so on. You have a name, a description, so very basic metadata here. If it is mandatory, and if it has a default value. A default value means that your model can work even if users do not provide that kind of input data. The value schema, this means URL, this is used by VLAB, and the target, this is very important. So where to store that specific input in the Docker container. The VLAB will instantiate a Docker container for executing the model, and it will ingest the data files into that container. You need to tell the VLAB where your model expects to find input data. So in our case, we have this data /s2.zip because our model, as we can see in the source code, expects to find the input data here in data /s2.zip and saves. So the output of the model is data /s2.png, and it is what we find in the target for the output value. So in our demo, we cut and paste this JSON file here, and we go to the next one. The next one is model scripts. It is the JSON file is called script.json. Again, it provides a schema, a JSON schema, quite simple. You need to provide which is the path on your repository where the file is, which is the target path, so again, where to copy the file on the Docker image, and the path type. If you want to, copy the entire directory, you can do it. You don't need to insert an element for each source file of your model. Okay, so in our case, we have two source code files, which are the run.sh and the Python script. Both are of type file, and the repository path is this one, because they are on the root folder of the repository path, and the model expects to find them on the root folder in the container. So again, first we need to create the file. Okay, and we cut and paste this.
Okay. I ask a quick question here?
Sure, please.
Aren't those two files already in the Docker?
No, those files are not this. You mean these JSON files?
No, the run.sh and the Python file.
No, they are not. And I tell you why. When we launched the container, we provided these mounting points, which means that the container reads the content of this folder from our local computer. But when you save it in a Docker image, it will not have this folder. This folder, let's say, is mounted on the fly when you launch the container. So those files are not there. And the reason is that it is up to the VLab to fetch the source code files and copy them to the instantiated container, so that if you then update the model, the source code of your model on Git, the VLab will automatically copy the new source files to the containers, and the new executions will use the new source files of the model. You don't need to change either the Docker image or the VLab, nothing. You just have to share on Git the new source files. I will cover the update of the model in the last part of this, but your question is very good. It is really about how Docker works. When you launch a Docker container, you can mount on the fly folders, and this is what we did here. But when you commit, so when you save that container into an image, this folder is no longer in the image because, how to say, it is volatile, okay, when you mount it in this way. And the same is for the test data. It is not part of the saved image. So to go back, yeah, please.
Okay, I understand about the save data, but is there a way to create a Docker where some files that we need are still there? So like if we need some data files to run the model?
Absolutely, absolutely, yes. You do essentially, this is part of the preparation. So here I have, installed software, which means I have created files, I have created directories, and so on. These all remain in the Docker image. What does not remain is what I have mounted here. The content, because this folder /test data and this folder /s2png are not part of the image which I have saved. These are mounted on the fly when you instantiate an image. So the next time that you launch your image, you don't have this. For example, okay, now the push has been completed, okay? I can quit here. I can quit my container. Now, if I rerun the same command with the new created image, vlaboratory /s2, what was the name, sorry, vlab, yeah. And if I remove these options of mounting on the fly the folders, we will see that we don't have those folders anymore, and we don't have the run.sh and so on. Okay, if I try to go to here, I don't have it. You see, this is empty because I did not mount any local folder on it. So just to complete this, we were here. So this is exactly where you provide the VLab with information about the source file. I hope this is clear. Please, if it is not, tell me, because this is important. Okay. Okay.
Yeah, and it was actually very relevant. Thank you for popping that. I was confused, and now I understand.
Good, good. This is exactly why we are having this. Very nice. So this way, I mean, of course, you could create an image which already has the source code, but that source code will not be updated if you just push new source code to Git. You need every time to recreate an image to update the VLab folder and so on. In this case, you don't. You do it once and it is, well, forever, almost forever. The third file.
That's just to say that I think this is a very good way of doing it.
Okay, well, thank you. The third file is where we provide information about which Docker image to use and how to launch the model. So the file is called dockerimage.json, and again, we add it to our folder. Okay. We are running a little bit late. Is it okay if we go 10-15 minutes ahead behind the schedule? I hope it is, so that we can complete this. Okay, again.
This is recorded, right? So if anybody needs to leave, you know, it is recorded. So if you can just put the recording later somewhere.
Sure, we will. So last file, Docker image. Again, you have the schema here, which describes its content and how to encode it. But in brief, you provide the Docker image, and in our case, we will provide the image that we have just created. You can specify some resources. So you might have a model which requires a lot of memory or CPU, these kind of things. So you can specify the amount of memory that are needed, but this is not mandatory, okay? And you can specify, well, this is quite default. You can look at Docker documentation for details about what entry point means, but in general, this is fine for everybody. And then command. So this is once the container has been instantiated, once all the data has been ingested and all the source code files have been copied, this is what VLab will execute in the container in order to trigger the actual execution of the model. So this is quite important. And in our case, we have first to activate the environment where we have installed the ESA software, and then we have to launch the run.sh. Okay, so we again copy this to our file and replace okay, the Docker Hub username we have used so far. So now we're all set. We are ready to share this. In order to share, we need first to commit the new files we have created, the JSON files. We need to commit a push to GitHub. So yeah, here I have some files which are from the IDE. Let me remove them. Okay, I commit this just to remove. Okay, And there we go. We have done the commit, and we need to push it. Okay. Push completed. Okay, this is for who utilizes different technologies than Git public repositories. VLab needs access to the Git repository. If it is public or private, doesn't matter. You can invite VLab user to a private repository, and it will fetch the code. So now we are ready to share this with in the VLab framework. So we open the VLab web page here, and we go to model upload. There we go. Here you have a form where you provide essentially the URL of the Git repository, so implementation URL, and it will be, for our use case, something like this, where again we replace the GitHub username with our actual one, which is this one. Then the model name, we can say webinar live test. Here you can provide some description of your model. Information about the developer, name, email, for us to be able to contact in case, and also for users that are aware. Okay, so you complete the form and you ask to validate. So what happens during the validation? VLab will fetch the Git repository and we look for the VLab folder and for its files. If they are okay, if they are compliant with the schemas and so on, VLab produces this diagram, which essentially reflects the content of the VLab folder. The inputs are here, the output is here, and so on. If everything is as you expect, for example, you don't have typos here or here, whatever, you can click publish. When you publish the model, it becomes available in VLab, and now you are ready to test it. You can click test. This will open the webinar live test that we have just published, and will display the diagram providing some more information. In particular, here we have the Sentinel-2 scene, which is a required data input and has no default value, so it is red and you cannot run the model. If you want to test the model that we have just uploaded, we have to provide a link that we have here in the documentation. There it is. This is the same file that we have used to create the Docker image. We provide it. It is available as a simple HTTP link, and we run. Okay, now the process the model has been queued, and here you have some basic information about the inputs which were used to run the model, and here you have the different statuses: queued, ingesting inputs, executing, saving, and completed. And you can also have some logging. This log is the logging of the model itself, not of the VLab infrastructure. So this is useful, especially in testing new models for you to be able to understand if something goes wrong, why, what's happening, and so on. Again, this will take some time. Now it is executing. And,
can I ask a quick question while it's running?
Sure, please.
So you had two types of value schema. One was URL and one was bounding box. Is there a way of telling the workflow that this input is a geos query, and then it will open up, allow you to select a Sentinel-2 image?
Let's say from the basic functionality, no, but the integration with Geos, takes place with the Geos portal and so on. So at the moment, no, but we can add new types. We have added URL and bounding box because they are the more straightforward things. For example, we might have temporal extent, so we can have different schemes or value schemes, there, and we will keep adding more. A geos query, yes, it is possible. So we can think of adding it. That's a good point. Yeah. So this is it. Well, now the model will run. We are waiting for this, and while we are waiting for the model to complete, maybe I can cover the last part of this. Okay. What happens when you update your model? Because this is going to happen. Well, it depends. It depends on which kind of updating you are doing. Here we provide a list of possible situations. We are trying to cover as much as possible, but there might be use cases or situations which have not yet been covered here. But for example, if the update of your model is essentially requiring to use more different libraries or different versions of existing libraries, you need to update the Docker image, and you need to update the reference to that image in the Docker image.json. You push it to Git, and that's it. On VLab side, everything is the same. At the next execution of the model, the new Docker image.json is read, and the new image will be used, and that's it. And here we have some other use cases. If the launch command has changed, the same as above. If you have changed some input file name, you need to change the IO description. The only use case which is at the moment a bit more complicated is the one in which you change the input set. So you no longer need only one input, but you need 2, 3. Well, in that case, you need, first of all, to update the IO description.json, push it to Git, but you need to republish your model. This is because the input set or output set change will essentially change this diagram, and it will change everything. So you need to republish your model, and you can request the VLab administrator to delete the old one because it will be no longer working. And while we are waiting for this to complete, I think, okay, here you see the logs. the same logs as we had in our local execution. It will be over in short time. I think I finished, and any other questions? The floor is open.
Hello, I'm George from SERF. Actually, you have shown the commands for Linux. Am I correct?
Sorry?
In order to set up the Docker environment, you have shown the commands in Linux. Is that correct?
I have shown. Okay, this is a good question. Your system, your operating system here is important in this. Sorry for scrolling so quickly. Okay, this is a command that you execute on your operating system. And in fact, here I have shown the Linux one or the Mac OS X one and the Windows one, okay? For example, this slightly different syntax. Once you are inside the container, so starting from here, this is not anymore dependent on your local machine operating system because you are inside the Docker, and this particular Docker container is working under Linux. So it doesn't understand Windows command. The other point where you might have different commands is at the end of the test, where you have to commit and push your image. But from what we tested, there is no difference for these commands between Linux and Windows. So the commit, the login, and the Docker push.
So for points that different commands should be used between Windows and the Linux, will you provide an alternative? Not for all points, for points needed in the documentation or not? Because I think most non-expert users use Windows.
Yes, in the documentation where we find that there are different commands to be used in Linux and in Windows, we add the information. Absolutely.
Okay. Thank you. Thank you very much.
A quick question: how do you connect workflows with storylines?
At the moment, there is not an automatic way for you to do that, something like the model upload and so on. Our idea is that in the model upload form, we might also have the possibility to pick up one or more storylines. That is an option. But what I did not say actually here is that you see here in the VLab page, you have, let's say, stable models, so the ones which have been tested and the ones which are under test. Here, if I close this, you don't have the under test ones, okay? When you are happy with the porting of your model, you contact us, you contact VLab administrator, and you say, okay, I'm good. I would like this to become a stable model. And in that process, we will ask you which are the storylines this model is connected to. So when then users browse the ontology and so on, they will discover your implementation as well. Oh, by the way, the execution has completed. You can click on show output, and here you have the PNG, which is loading here. Any other questions?
Question about the programming language. You show us something in Python. Which are the limitations of Docker in terms of programming languages?
Good point, Johan. We have been testing with other modelers. EODASM is in Python, so we are in contact with Mohid team, EPFL, Instar. I mean, already 3 or 4 groups, Deltares, of course. They are testing the porting of their models with different languages. For example, Deltares is using Fortran as well as Mohid. As far as I know, Mohid team succeeded in porting the Fortran compiler, installing the libraries. I think there is some, the only one remaining issue with them is about the licensing of one of the required libraries. We are going to look into that next week. Well, so far I have not done anything in creating the Mohid image. For example, they did everything by themselves, so they really did a great job. Deltares also has Fortran images, so that seems to be fine. I think Instar is working with the NetLogo language, and they are trying to do the same. We didn't hear in the last 7-8 days, but they are working on it. So in principle, Docker is neutral in respect to the programming language. Of course, there might be some issues. We don't see them at the moment because, as I said, it is neutral. Docker was born to address exactly that point, to be able, let's say, to ship software and applications really in standalone containers where you can provide it. If some issue comes up, we will see. But at the moment, I do not see issues related to the use of different programming languages. We are going to work also with Carmela, who is developing in Python, in MATLAB. So that would be another very interesting use case. We would like to see some modelers using R. That's another very widely used programming language for models, environmental models. So so far so good, and I really think this way should. I don't see any issues at the moment.
Can you execute compiled programs in the Docker?
You can execute either compiled programs or compile them on the fly and then execute the compiled. Because here in the Docker image.json, you can essentially provide a list of commands. So, Python does not need to be compiled, so it's not here. But for example, if you have Java or whatever, you might have first the compile command and then the execute. So,
thank you.
Can I ask, you mentioned MATLAB before, so MATLAB itself is require licenses, but you can, the MATLAB compiler runtime doesn't. So would the approach in this case will be to have the MATLAB compiler runtime in the Docker, and then you will in the Git to have the pre-compiled MATLAB scripts. Would that be the approach?
That is what we are thinking. Yeah, exactly. But in general, you might also have, the actual MATLAB with your own license. You are providing this to the VLab, not to the entire world. So also the licensing somehow is not should not be a big issue. But that is if the issue is the licensing, it is independent of VLab or the Docker technology or whatever. If you can't use that kind of licensed software, it's not a technology issue actually. Okay, I think Yanis, what do you think? I think we can.
Yes, I think we can close the session. But please, for the ones who attended, if you have time to test your models by the next webinar that will take place next Friday, 2nd of February, same time, meaning 10 o'clock Western Europe time, please do so and write down any question you might have, any issue you face, or give us just feedbacks. It would be really useful for the next steps of these developments.
Yes, in general, the idea is that the next session will be about collecting your feedbacks, testing all of this, and of course issues, even bug reports and so on. Of course, during the week you can contact us, and we will try to be as responsive as possible, and we try to wrap up, collect everything together in the second session.
Yes.
Excuse me, Maria speaking from University of Granada. Would it be possible, because I guess you will get some requests during this week about people having error messages, would it be possible to include these error messages and the solutions to them in the documentation?
Absolutely, yes.
Yes.
Yeah.
Sure.
And yeah, sorry.
I mean, we have also taken note of many of the questions that were asked today, and we'll try to do our best to implement them also on the online documentation as soon as possible.
Great, thank you. And I have been trying to follow the example, but I'm having troubles, and I don't know if it's because I'm using the Docker toolbox or because of the example itself. I don't have Python installed in my computer, so I was wondering if I would need to have it locally in order to get the code to run.
No, you don't need to have it locally.
Okay.
And as I was saying, yeah, this is exactly what we need. So
Okay.
of course you will write to us, and we will try to help you as much as possible.
Yeah. Okay.
Right, but you need to start. I think you started the Docker from Anaconda. If she doesn't have Anaconda installed, can she start the Docker with Anaconda?
Yes, she can.
Yeah, that's what I was thinking.
No.
Yeah?
Yes, absolutely, because that is exactly the very important point here, is that what is running inside the container is not needed on the host system, which is your PC in this case. That's exactly the point. When I start the Anaconda image, it means that I am instantiating a container, a new container which has Anaconda installed in it, but not on my local PC. So please, Maria, I would ask you if you could send me, of course, to me, Paolo, Yanis, sorry, the error message you are having, and
Sure.
we try.
Yeah, I will. I'm just gonna try to reinstall Docker, because I think it could be that in my trials I get some troubles there, and then I cannot go further because of all this. So I'm going to start from the beginning. I think another useful thing for the documentation, and someone just asked about it in the chat, could be to have the documentation separate. Well, it's a bit related to what he said. To have the whole flow that we have to follow based on our system, so that we don't need to see mixing commands for Windows and Mac and different Docker or Docker toolbox. So maybe there can be some branching there so that each one has its path.
So the idea you are proposing here is to have essentially, I say duplicated, but they are not actually duplications, because so same versions of the same documentation, well, different versions of the same documentation with the command for the different operating systems. Well,
I can imagine that's extra work for you. So if it's too much, that's fine. But yeah,
we are trying to make things as easy as possible for you. So if this makes, as I said, there are just so far in the documentation there is only one command which is different from Windows to Linux. That's why we didn't, clone the page. That is the idea. But for example, I see, and you are not the only one, that many of the modelers we have contacted are having some issues with this Docker toolbox.
I'm stuck there. Exactly.
Probably we need to expand the documentation for Docker toolbox installation with some tips also for the models, because usually we refer to online Docker because of course they keep their own documentation, but I understand and I saw that the Docker toolbox is not so well documented there either. So good point, the Docker toolbox. Yeah, okay.
Yeah, thank you.
Okay. Anything else?
Just to say, from Work Package 6 perspective, I think I want to thank you all for doing this webinar. I think it was really very good to see the progress in the virtual lab, and I think it's been the best explanation of it I've heard so far. And definitely the functionality, the basic functionality is there, and I'm happy that everything worked. We could show it in real time and not in a quick view video. And I also congratulate you on what you've done. There is a lot of things that can be improved in the future. So I'd be happy to talk with you. Maybe we will do it in the General Assembly on what can be improved in the future if we have time in ECOPOTENTIAL or afterwards. But thank you.
Thank you, Guy. Thank you very much.
Okay, so thank you very much, Guy, for this last comment. So I think we can now close the session and meet all of you in 1 week and 1 day. Thank you also very much, Mattia, for everything you've shown us today.
Well, thank you, Yanis, and thank you all the participants. Talk to you in 1 week. Bye-bye.
Okay, bye-bye.
Bye.
Bye.